In this video, we will talk about how to find the rank and the nullity of a matrix. So the rank is simply the number of pivot entries in the row echelon form of the matrix, and the nullity is simply the number of columns minus the rank. So let's check out an example. Let's say we have the following matrix here, and we want to find the rank and the nullity. Well, the first step is we need to convert this matrix to row echelon form. So the first pivot entry in this matrix is this one right here, or the first non-zero value in the first row. To get a matrix into row echelon form, we want to make all values below that first pivot entry into a zero. So we want to convert all these ones into a zero. So notice we could just say, let's do row 2, let's make it row 2 minus row 1, because we would get 1 minus 1, which would make this a 0. We can do the same thing with row 3. We can say, let's make that row 3 minus row 1, because that would also be 1 minus 1, which would make a 0 here. And then we can do the same thing with row 4. So we can say row 4 will become row 4 minus row 1, because that would also be 1 minus 1, which would make a 0. So let's see what that would look like. So the first row is not going to change at all. We'll just rewrite those values. The second row is row 2 minus row 1. So 1 minus 1 is 0. Then we do 3 minus 2, which is 1. 6 minus 1 is 5. 0 minus 3 is negative 3. And 2 minus 2 is 0. Now row 3 becomes row 3 minus row 1. So 1 minus 1 is 0. 2 minus 2 is 0. 1 minus 1 is 0. 3 minus 3 is 0. And 2 minus 2 is 0. And row 4 we said will become row 4 minus row 1. So 1 minus 1 is 0. 3 minus 2 is 1. 2 minus 1 is 1. 2 minus 3 is negative 1. And lastly, 0 minus 2 is negative 2. Okay, so here's our first pivot entry. We have all zeros below it, so that's good. Here's our second pivot entry. We need to make sure that there are all zeros below this pivot entry. So this one right here needs to become a 0. So how can we do that? Well, we could just say row 4 is going to become row 4 minus row 2, because that would be 1 minus 1, which would get us the 0 that we need here. So let's write that down here. Let's say row 4 is going to become row 4 minus row 2. So let's see what that looks like. So the first 3 rows will not change. But row 4 will become row 4 minus row 2. So we get 0 minus 0, which is 0. 1 minus 1 is 0. 1 minus 5 is negative 4. Negative 1 minus negative 3, so negative 1 plus 3, that's a positive 2. And negative 2 minus 0 just stays negative 2. Recall that another one of the rules for a matrix to be in row echelon form is that if there is a row of all zeros, that row should be at the very bottom of the matrix. So this row of all zeros right here should actually be the very last row. So what we can do is we can just swap row 3 and row 4. So here's what that would look like. Okay, so this matrix is now in row echelon form, or REF for short. So what we need to do is identify the pivot entries. So here's the first pivot entry. It's the first non-zero value in the first row. Here's the second pivot entry, and here's the third pivot entry. And notice that there is no pivot entry in the fourth row. So there's a total of 3 pivot entries. So we would say the rank of this matrix is 3, because it's simply the number of pivot entries when the matrix is in row echelon form. And the nullity, we'll write N for short, is simply the number of columns minus the rank. So how many columns are there? 1, 2, 3, 4, 5. Minus the rank, we just found the rank, is 3. So 5 minus 3 is 2. So the rank of this matrix is 3, and the nullity is 2. And you can use this exact same process to find the rank and the nullity of any matrix.